camera webinar series. This is the last camera webinar of the series we have for this week. So yes, so as Dervla mentioned, traditionally, we have USB 2 camera solutions with ISPs integrated within the modules, which has been adopted broadly for client product platforms such as the Lenovo ThinkPad products, which benefits from various cost reductions, as Suyan will get into, along with the various design optimizations. That said, there may be opportunities to dramatically improve the image quality for emerging hybrid work environment use cases. And so we are incredibly delighted to have Suya Yang from Lenovo, who's going to provide a detailed view of how they are providing best-in-class video conferencing solutions by utilizing the MIPI interface solution and leveraging the superior image processing capabilities within SoC platforms. Suya Yang is a hardware engineer on the system design strategic team from Lenovo Japan LLC, and his work focuses on introducing innovative ideas and designing new solutions for ThinkPad products. His experience covers wireless communications, display, touch, IC developments, and system platform design. Prior to joining Lenovo, Suya Yang also worked in Sony in Tokyo, and he focused on bringing up various hardware platforms for developments, and at Synoptics for various automotive TDDI chips. So welcome, Suya Yang. We are delighted to have you.
Hi, everyone. Hey, hi, Harung and Deva. Thank you for the introduction. And my name is Chirung Yang, and so I'm very glad to be here and to share our story about, Hello, everyone, and thank you, Harung. I think you hear me, right? And so Delva, and thank you very much to introduce me. And I'm Chirung Yang from Lenovo Japan, the ThinkPad team. So I'm here. I'm very glad to be here and sharing the stories that we are delivering the best camera image quality using the MIPI interface on the ThinkPad notebook. So I'm working as Harun also introduced, I'm working in the system design strategy team. And this team that's fund innovations and to introduce all the new ideas into the ThinkPad product. So here, what we do here is just from maybe 3 years ago, and we were thinking about a lot of candidates, and finally we deliver this kind of a solution. And today I'll share this story. Okay, so what's the background of this development? So we saw our customer increasing needs in the area of hybrid work, of connecting dots by the power of technology. So especially in the COVID, so everyone in the work from home and start this kind of hybrid work. So when someone work in the cafeteria and someone work in home and someone work in the office, and this is such kind of solution that makes people it's very difficult to do the face-to-face meeting, and so it's our pinpoint that because traditionally we use the tiny image sensor and with the tiny USB, and doesn't provide the good quality for the customer. So this is the background we're starting this. And also during our own research, we found that the percentage of the online meeting is you can see it's a 25% in the 2018, and it increased to the 66% in 2021. So this is a reason why we see our customer needs, and we must provide some answers to our customers. Okay. So how to do this? So well, I think as a hybrid work project progresses, so can we facial conversations and emotions expected in the same way as real life. I think it's a key to success. So ThinkPad team is responding to growing these needs to emphasize. The first one is to improve the camera quality, image quality for the online meetings. So it means that we need a high resolution and low noise and raw data with MIPI. So MIPI is used in the mobile, widely used in the mobile industry, but is not well widely used in the laptop industry. And also, not just a camera, also we are thinking of the improvement of audio quality as well to achieve clearer conversations. So we are also thinking about the implementation of AI-based noise reduction technology and selection of low noise microphones, actually. And also we are improvement as a collaboration device, as ThinkPad product as a collaborative device, implementation of automatic mute function and mute alert function, and also power consumption improvements in UC applications. So this is something we are focusing on. And so we deliver this product in the X1 Carbon Gen 10. So you were talking about MIPI camera subsystem design in laptop. It's not easy because we have several pinpoints here. So you can see the traditional camera system in the laptop. And here is in the above diagram, it shows that the camera system so far is a tiny camera and use SP and it compress data and where the USB interface to the SoC. So it's a traditional way and very simple. For the system design point of view, it's very simple. So for the MIPI, we transfer the raw data here, and here is some difficulties, and it's a lot of cables, a lot of signals, and we have the trees is so long. It's because the laptop is a different form factor from the mobile phone. So from camera, usually put on the top bezel of the laptop. So from the top bezel to the SoC is a long journey, and also with a lot of signals. Okay, so here is from system design view, it's not easy. So that's the reason why the laptop doesn't adopt the MIPI interfaces so far. And also in the below picture, you can see that this is what we designed here. And so you can see it's a very, very complicated system, but we make it done. Also, this is in the right side, you can see how we are focused on the three major innovations in this kind of a MIPI camera design. The first one is we designed for the IR and RGB and IR camera separately. So one is for the Windows Hello and also for the web conference. And also for the lens and resolution, that's the image sensor, and we choose the FHD resolution. And nowadays we even go more. And this is we start from the Full HD, and because traditionally we used to use the HD sensors, very tiny one. And here we introduced the Full HD resolution and bright 2.0 lens. And this high resolution and bright lens make it easy to tell facial expressions for better user experiences. And also is that we are trying to leverage the powerful IPU inside SoC. So we need to transfer lossless raw data via MIPI interfaces. And so we connect to the powerful SoC IPU to achieve best image performance for better user experiences. Okay. So here is the apple-to-apple comparisons. You can see is a product that's developed in 3 years ago. It's just a HD USB camera, and you can see it in the right side is our new X1. It's a generation 10, and you can see it's a full HD with MIPI solution. So you can see the difference is obvious. We can see all more details. We can see the red color. All the things is better than the previous one. Also achieve this that the mechanical design is the key as well. So we are design we need to hide the two cameras because we have RGB camera and also we have IR camera. So we need to design a special shutter, physical shutter, to hide two cameras at the same time. And also we need to minimum notch design because our design is a very narrow bezel here, and this special effort will be put here to make it look beautiful. And also, we have needs to, some low-cost solutions as well. So we need to design common ones, common camera module, and across X1 series. You can see it here. We also design different camera modules, but fit it into the same mechanical design. And here is also some innovations we need to consider in our design as well. Okay. So here is some summary for this, what we design in the camera subsystem. Because of the COVID, so realizers of image quality needs from cameras, we saw this and we need to provide answer to this. So improved resolution and detailed expressions from camera image and more natural image quality. Also improved the image brightness of online meetings environment from anywhere nowadays. And also, we are collaboration for the best virtual experiences in implementation and development from the POC. And we start from POC 3 years ago in order to quickly respond to the discontinuous changes in the work scales. And not only the hardware, but the consistent system development process from the advanced development stage to mass production development and to tuning. And also here, because we use the IPU, the powerful IPU inside SoC, so we do the image evaluation adjustment in-house as well. Collaborate with Intel, for this example. So you can thinking from the user point of view, and use image quality such as color fidelity and white balance was just over half a year. So this is a completely in-house tuning here. And also evaluation adjustment under various corner conditions such as dark room and backlight extra. So you can see from the right corner, so it's the before and after. So you can see the color and also white balance is tuned well. Okay. And also because we can using the MIPI, so we think more about this. So it's not achieved by the traditional solution. So here we also design a computer vision subsystem in our product. So computer vision. So it's not a new word, and so it can achieve traditionally achieved by the powerful CPU or the graphic cards. But here is that we are thinking about a low power solution as a edge AI computing. So proposal of this is new experiences that achieves both power saving, usability, and privacy. And here is the key features that what we can achieve by this technology and our solution. So we need to make the ThinkPad product as smart as possible, and also ensuring the privacy by using AI machine learning technology. And you can see here is the three features, and the first one is power consumption reduction by behavior recognition. And in the middle, you can see that is effective user space by sharing camera image sensors. And also that ensuring privacy by isolating it from the CPU. So it means that we are ensure our customer that no privacy concerns on this. And for user point of view, and here's the three visual points from conventional HBD. So we usually use the radar or top sensor to do this HBD human presence detection. And here is we can use the image sensor and subsystem, this AI subsystem, to do this and more. And definitely we can do the user presence sensor it's working as a user presence sensor. And also we can save more power by the PC usage detection. For example, if you're not looking at the display, and the display brightness will be reduced automatically, and just be this all depends on the user's behavior. So our study is can save 6% to 14% power consumption reduction in our Gen 1, the first generation implementation. And also the third one is for the privacy alert. And it's also support in the DC mode. So because so far we can implement this in the CPU. We use CPU to detect to introduce feature, but in this case, as mentioned, we are here to implement a low power solution for this privacy alert. So it means that even in the DC mode, only battery drives all the system, and we also can have this feature online. And so here is the design story of this subsystem, computer vision subsystem. And we are trying to shooting of the evaluation. We're shooting evaluation images and sorting word, feedback on the judgment result. We collaborate with our supplier on this. So based on the diversity such as people race, and more than 4 million images in total are used for the machine learning here. And also during the development, we solved misjudgment problems such as the tail of the face, with laying down, room blackness, posters, door, and t-shirt patterns. So it's not worked well at the beginning, but finally it's worked very well during our test. And also with establishment of evaluation criteria while developing POC. So because it's quite new for us, so no one did this before, so we need to define our own evaluation criteria. So while developing these new functions and also sharing the POC result and formulating evaluation criteria with the product assurance and quality assurance teams, and brush up for mass production. So it's a global collaboration on this one as well. And also is that, you can see in the previous slide, it's very complicated system for laptop. So on-site factory support for the total of about 300 days into delivery to the customer. So in order to deliver high quality product to users, we perform on-site factory support even during the COVID-19 pandemic, and including on-site adjustment to achieve the performance level of the customer expectation from computer vision subsystem. Okay, next slide. So in near future, so this is something we started 3 years ago, and so in 3 years ago, and now finally we deliver this product is in the mass production last year, and you can see it's a very complicated subsystem, and we did a lot of effort on that. So here, why I'm here to introduce this is that we hope that we are expecting other participants, including the SoC vendor, image sensor vendor, and also the IP vendor in this industry to invite this, to think about new solutions for the future. So here is some, we also found in the DeFi or CSS spec, we also have to define this, but even we talk to the image sensor vendors and also SoC vendors, so it's not implemented. It's still an old version of the spec. So because of that, we have to design. We have to put a lot of effort on the system design, and especially the wear reduction, the wear count reduction. And also we put a lot of the components there to make sure that signal should be good. Okay, and also we are some special design for the laptop because it's a long journey from the image sensor to the SoC. So this is our pinpoints, and we did a lot of effort on it. And the next step is that to talk with all the members here that find a best solution and for the future product. Well, we are starting some discussions as well, and for the power integration and signal integration, and also some low cost cables as well, solution as well. So it's from the consider from the system topology from point of view, and we already started this kind of activity, and looking forward to the new product, new innovations. Okay, that's all from me, and thank you for listening.
Yeah, thank you, Shuya Yang. This is very interesting presentation at so many different levels, and the timing is quite good too. Uh, just to start off, some questions. What is the biggest challenge for integrating the MIPI CSI2 based interface in the ThinkPad or other notebooks from Lenovo?
Yeah, thank you. That was quite a good question on that. So you can see, I just open this slide here. This page is tell us that in the traditional our implementation, we use a tiny SP on the top. So so now we see some some powerful SP in the SoC. So that's the reason we introduced MIPI, but we saw a lot of difficulties there. And I think there are two main issues to be solved here. The one is the long routing trace length due to the COM from the factor. Okay, that's the one thing. And the other one is that limited numbers cables that allow to be routed through the hinge, and due to the mechanical design. As you know, the ThinkPad, we have the product. We have you can rotate it 360 degree and work as a tablet. So we have a special hinge design there. And to solve this, we start to how to solve this above issues and design, and in our internal POC. So we have we have several candidates on that. So, and here you can see, as mentioned, we need to design a repeater, that signal repeater and signal aggregation logic. And also we have to design the new mechanical and such kind of things. So these are the design behind the display panel and placed in the middle between the camera module and CPU. And we think it's the best place for this such kind of design. Okay. And also here is the, we are thinking about computer vision as well. And so all of this, that's, we need no innovations, design items here, and to solve the issues mentioned above. Okay. And here, so this is a integration, right? So it's not all we don't have such kind of a solution so far. So we choose the FPGA and also the MCU to implement this. And it's very hard work here. And the other one is that the IQ tuning. So it's the first time for us is to the in-house design on this, to the IQ tuning. And because we used image sensor unit inside SoC, okay, so we must tune it, and with this powerful IPU, that we want to achieve the better performance than the traditional USB 2.0 ISP solution. So we did a apple-to-apple performance comparison day by day, and so this I think these are two main issues that we need to solve during our development.
Yeah, very, very well said. I, just to kind of zoom out a bit, the solutions that you have, though the incumbent solutions are the USB 2 solutions, and the ISP is integrated into the camera module. And the one that you're presenting here is a solution whereby you are leveraging the ISP from the SoC to help realize the superior image quality. Is that a fair statement?
Yeah, sure.
So from that perspective, you mentioned calibration and tuning. So what I'm gathering is that if the ISP and the sensor, if they are all integrated into the camera module, calibration and tuning is done at the module level. It sort of becomes a plug and play. But when you are now using an ISP from the SoC, there's additional effort that needs to be deployed, engineering effort for calibration and tuning. Would that be one of the differences transitioning the ISP into the SoC?
Exactly. Because usually the ISP, the module design house will tune everything for us. And now here is that we use the SoC, and our module house don't have such kind of environment, and they cannot tune by themselves and use this kind of SoC. So we established our own in-house lab to tune in this. So it's something quite different with the traditional way to do this. And the benefit of this is that we can control this in our in-house lab, and to make sure that every module performs the same. So we have different suppliers, and so we tune the module in the same way and make it looks in the same provide the same user experience to our customers. I think it's a quite benefit. It's a big benefit to our customers as well.
Oh yes. I can see a great deal of doors being opened by the second approach, by leveraging the higher caliber ISP in the SoC. You also referenced the possibility of vision being used by leveraging AI engines. From that perspective, like under the umbrella of ISP, we have things like lens shade correction, white balance, pixel defect correction, gamma correction. Do you envision the use of AI engines for things like scene analysis or denoising, demosaic, TNR as well?
Very good question. Yeah, Haran. So I think it's the next step. We're working on it at the moment. And here is we just use this AI to do some, human presence detection, and also do some for the more smart features that adaptive dimming. So it depends on the user's behavior. But on the other side, it will be help us to make the image quality much better, because he knows where you are, what's the environment, ambient environment you are. So we can based on this, and he knows where your face, and he knows the conduct of all the things such as conduction and the light, or all the things he knows. So it knows. So that is we can take the advantage of this, and for the camera image quality tuning as well. So we're working on it at the moment.
That sounds very exciting for sure. There's another question from your perspective, from Lenovo's perspective. Looking forward, can you perhaps comment on the outlook of the MIPI interface adoption in notebooks and client products?
Yeah, so I think in our portfolio we have more products with MIPI interfaces, and now we're working on it. And we are also, as mentioned, we are finding new innovations on that for the power integration and signal integrations, all the things. And I think will be the MIPI interface will be adopted by the laptop more and more. So this is our plan. And but on the other side, we see this kind of difficulties, and we see it's a very complicated design, and also see the BOM cost is so high, because we need reduce all the things, and so we're working on it as well. But in my point of view, in our product portfolio, we are increasing the MIPI camera at the moment.
That is quite encouraging for sure. So in the first two webinars, we presented exactly what you are bringing up, Shuyu Young, which is for client products, it is incredibly important to reduce the number of wires using USL and also facilitate longer reach, like say 24 inches to 34 inches, natively supporting long reach with a total channel loss of maybe around 24 to 31 dB channel loss. To the point that you're mentioning, like even like the limitations that the USB 2 may be having, such as like map limited to 720p, and maybe there's a desire to go to 4K, may result in higher bandwidth needs, like maybe around 4 to 5 gigabits per second. Absolutely. So there's a question on the chat from Ethan, and this is something we presented in the first two webinars under the umbrella of USL. We are presently exploring two flavors of USL. One is using DeFi embedded clock mode. It's a two-wire solution, again, facilitating the longer reach. And the second exploration is using the ternary solution, using C-Fi 16B or 7S. Question from Ethan is that when you are referencing USL for client platforms, do you have a preference between like the DeFi two-wire signaling versus the three-wire C-Fi signaling?
Yeah, we'll have some research on it as well, but it depends on the SoC or the image sensor support. So far we didn't, with all the sensors we see is that yes, recently I saw some sensors that support C-Fi as well, but at that time we didn't see any sensors support that. For our, we don't need 20 million sensors because for laptop we don't need that. So our range, I mean, we are searching for a full HD at that time. So in that time, so only we can see, and on markets is only support the DeFi. So that's the reason we use the DeFi here. And also we are, yes, of course we are thinking about that, but they also need the support from SoC as well.
There is a question from Kieran in regards to tuning and ISP control. I'm presuming the question is in regards to tuning the ISP from the SoC. Do you have any plans to look at supporting users on non-Windows operating systems such as Linux? Or are you just limited or focusing only on the Windows OS as far as?
No, we are support Linux as well for the MIPI camera, and we have tuned this, and also you can see some we opened some source code on the open source platform as well. And also we provide the IQ profile, the main quality profile for the Linux as well. So you can use the MIPI camera with the open source driver. You can use that. So not limited to the Windows. We also support Linux here.
Great. That makes a lot of sense. I'm also going through the chat window to see there's another question from an engineering. This is a question from Eric. I'm going to transcribe a bit here. Oops, there's a window popping up. Okay, right. So a question from Eric is, from an engineering process, system analysis perspective, can you elaborate a bit on the process used for the MIPI-based camera versus, or using MIPI-based camera to replace the USB solution that was previously used on your platforms? And when you're running the apple-to-apple comparison, how did you determine the benefits and the advantages of the MIPI system?
Yeah, of course. We did a lot of research and we did a lot of comparisons on that. And also we are looking the other product, I mean, from other companies as well. For example, from Apple. And also we do some comparisons from mobile as well. So mobile is use the MIPI and give us a very very good image quality. So we are looking at it, and also for us. And so far we use the USB, and you can see. Let me show you the picture here. You can see is apple to apple comparison. We need to make sure all the things is in the same on the same page. And yes, you mentioned there is a lot of potential risk, so that's why we didn't go to the mass production at once. So we started this from 3 years ago. So we did a lot of work. We have 3 candidates of the POCs, and we also complete all the things. And finally, we choose one of the candidates, and it shows better cost and better quality and simple design and also something of that. So that's why we just confirm all the things before go to the mass production, and we think it's okay, and then we go to the mass production to reduce risk in the mass production. So that's the process we did so far, and we did a lot of work, research, do the apple to apple comparison, and we did a lot of POCs, and then make a final decision to go with MIPI camera.
Got it. I also see one more question from Xiaofeng from the audience. The question is, what is the maximum transmission distance supported by MIPI CSI2 now? Is it 4 meters? And the second question is the DeFi rate of MIPI CSI2 related to DeFi version used? Is the maximum speed 2.5 gigabits per second? So that's an interesting question.
Yeah. The first one, during our experiments, we did a lot of work on it, and we see some potential. Is supports up to 50 or 50 centimeters, and here is our experiment result. But I think in the defined spec, it defined as 20 to 30 centimeters. That is defined in the spec. It also depends on the receiver side. The receiver side has a more powerful and a lower BR, it can crack all the code, and we can transmit along. But here's limit during our experiment, and we measure the signal by ourselves as well. We see the signal, we see the I pattern, and we see all the electrical characteristics there. I think is maybe 30 or something is the max. Is if you're up to is over to that distance, we see the risk, and so we need to do some special ones. For example, make the layout as perfect as possible, and it can transmit a longer distance. So I think in the MIPI step is very because so far is a work it designed for the mobile, right? So the sensor is just besides SoC, so we didn't have such concern so far. But for the laptop form factor, it's a different story, totally different story. So that's why we did a lot of work to how to make sure that we won't see any problem with our product. And we did a lot of tests on it, and so far we no single case that from this kind of signal problem. And so far it's also sold I think it's most recent millions of product. The attach rate may be not 100%, but we sold a lot of products, and so far we didn't receive any issue from the market. I think our design is good. And also, the second question is that the MIPI version, I think it's a very not so high. I think it's a 1.2. It's a very old version of that because the sensor is not so not nowadays. Sensor is a Full HD sensor, so it doesn't need the new DeFi, and the speed, max speed, we can adjust. Depends on the cable design on it. Some product we low because we want to make sure the SI look good as possible. So we set Android 800 megabps per lane, and the other product we set it at 1.5 gigabps. So it depends on the product. It's a different. The max is a 2.5, and I think is during our current topology, the 2.5 is a very high risk for us. So I think now we need to keep under 1.5, and based on our experiment.
Fantastic. I'm going through the list to see if there are any further questions. Right. You mentioned there may be the camera sensor deployments at the top of the module. We may have RGB and IR, two separate sensors. Would it be helpful to explore solutions to support more than just one sensor coupled to a single MIPI port? Do you see benefits for some exploration supporting more than just one camera sensor by one port?
Yeah, one camera and one port. Yes, for us is for this product I showed here. Let me move back to the slide. It's very challenging because we have two sensors. We need two MIPI port, and we need a lot of double the control signals as well. And and also we have IR, and also we have IR LED, and also the indicator LED that to comply with Microsoft's standard the specification. So it's very challenging, and but the benefit is that we separate this kind of solution into two cameras, so quality is better. So far we use hybrid sensor. It's one sensor, pixels is some for RGB and one is for the IR. And we saw some crosstalk as well, and we saw the image quality is not good. But before the COVID, this kind of needs is not that high, so I think is a good in that area. But after COVID, everything changed. So that's our customer cannot meet such kind of performance, and we hear a lot of voices from market, and that's why we separate sensors, and one dedicated for the web camera, and one is dedicated to Windows Hello. So both performs very well at the moment, and during our comparison, in-house comparison. So even we saw some challenges on the system design. But for our customer, we can deliver the best image quality, best user experiences. So that's why we choose to separate sensors here.
That seems to make a lot of sense. Purely from a physics perspective, I'm assuming by separating the sensors, you can gather more photons by having a dedicated RGB sensor array as opposed to a hybrid.
Yeah.
A quick question on page 11.
Yeah.
If we could transition to page 11. Right. So here on the middle diagram, it is quite interesting. And the reason it's interesting is that like today, we see the emergence of transparent OLED panels and oftentimes, there are projects or talks about the possibility of maybe having a camera behind display. Do you see that as a forward-looking possibility sometime? And if so, maybe again, how MIPI CSI2 could be of help for such like forward-looking developments? Welcome your thoughts.
Yeah. Good question. So Harold, I won't talk more because yeah, we are thinking some kind of development as well. So yes, we are thinking of that, but we saw some difficulties, and also we saw some reflections, and we did a lot of experiments, and that's something we know we need to to solve, and I think we need some time to solve all the problems we saw during our POC, and so exactly we are looking at it as well.
And so to the point that we were discussing earlier, having the the superior processing that is available within an SoC
Exactly.
may be of incredible benefit when you're exploring perhaps some futuristic solutions of that nature,
Yeah, exactly.
right? So,
Exactly. Yeah.
okay,
Also, it's not just this kind of processing, also the mechanical design. That's it's more difficult, and we will leverage the powerful SoC to do that as well. And now we do some special post processing and to remove all the artifacts introduced by the this kind of design. And so we're looking at it. So yeah.
great. I'm just going to have one more quick check on the chat window. Right, there's a question from a member. From Lenovo's perspective, are you by any chance looking into reducing the cable cost
Very
for
good question.
MIPI-based solutions?
Yes, very good question. We saw that maybe the cable cost is so high compared to the traditional solution, and we are trying our best to reduce cost. As mentioned in the, let's move back the page. I think it's page 6. Yep. So here you can see that we do the signal aggregation and here. So that means that for the system we only have a USB interface, and from our mid board you can see that. So we aggregate all the sendback signals, and so that's why you can see a very narrow cable to the system. That's something we have done to reduce the cost of cable. So cable cost is the way it depends on the physical size. So if the physical size is big, and you can cut less cables on that, so the cable cost will be increase double or triple, something like that. So to make the physical size as small as possible, so we can save cost. So that's the reason we do the aggregation here. And this is at that time we started 3 years ago. At that time, no one did that. So this, I think, ThinkPad product is the first in this industry to do this kind of things. And we done it, and now we reduce the cable cost as much as possible. And in the future, and this is our first generation product, and we're continue. We won't stop. So we reduce the cable cost as more in card the design. And so we'll see all the possibilities that reduce the cable cost. And so far, it's not enough. It's still under development. I think the design of this generation in current development, and almost the same, a little different, but almost the same with the cable cost of the USB solutions.
Makes a lot of sense. Shui Young, I'm thoroughly loving this moderator role. I feel like I have one of the best jobs in the world right now. So thank you. And I would also say that your presentation today very much complements, what Rajkumar Nagpal delivered on Monday, and specifically looking at the possibilities of using ECM as a two-wire solution for client platforms, using the USL solution that you mentioned. And George also with C5 also exploring the possibility of facilitating longer reach. I would mention to the members that these are present explorations within MIPI as well, addressing the very, very important system engineering problems that you're bringing up, Shui Yang. So, yeah. Thank you so much for this incredible presentation. I think I learned a lot myself, and I'm also thank the audience for the high caliber questions on the chat window. Again, Sui Yang, this was fantastic. Enjoyed meeting you virtually, and thank you for this wonderful webinar.
Okay, thank you very much.
Bye, everyone.
Thank you. See you. Bye bye.